Hello everyone, this is Vidit again from TechSpot, bringing you another session covering data engineering Q&A. And in today's session, we're going to talk about Lakehouse Architecture and one of its prime components, that is Iceberg people. So before jumping in, I just want to mention that last couple of sessions, especially the one with the Delta Lake and this one, so these are beyond the primary scope of data engineering, meaning these are the latest tools or stacks that have come up in the data engineering domain, which was not there, suppose, say, 5 to 6 years ago. So having a good concept and knowledge of all these things, especially the Delta Lake and the Lake House, will not only help you in cracking the interviews, but where the interviewer will also understand that how much you are updated with the latest stacks that are trending in the data engineering market. So without further ado, I'm going to start off with my brief introduction. I have been working in data engineering domain for almost 9 years with various projects and involved in building data pipelines for several clients. I also train candidates in this field to help them build an interview profile with our comprehensive course covering all the necessary topics of data engineering. So let us come to understand the meaning of the word lake house. So if you remember in one of the very early sessions, I did talk about data warehouse and data lake, right? So I drew the differences between the two and how I mean in what use case we should be using the what option, right? So this is something like a hybrid. So it's basically using the features of both data warehouse as well as data lake. That's why the term lake house has come in. So if I just look at the definition, Lakehouse architecture is a modern data storage architecture that combines the best of both data warehouse and data lake technologies. It allows organizations to store structured and unstructured data together in a single location, providing a unified view of data for analysis and reporting. So it is basically a hybrid of data lake and data warehouse where I can keep both the structured and the unstructured data. Whereas in data warehouse, it wasn't possible, but it also has the quality or the features of the data warehouse, meaning I can do the CRUD operations as well. So if I talk about its components, so there are three primary components of it. One is the delta lake, which we have discussed in the previous session. Second one is the iceberg, which we'll be discussing today. And the third one is hoodie. Hoodie is another component or another delta lake format, which is being used in some of the projects, but we won't be talking about it over here. The most the most popular one, if I want to say, that is the iceberg. And in AWS also, if I'm trying to build a lake house, iceberg is the first thing that comes into everyone's mind. And Delta Lake, whereas it's good when you're working with a database platform because inherently database has those configurations which works well with Delta Lake. Okay, but there are some differences in between Delta Lake and Iceberg, so I will talk about that later as well. So Apache Iceberg tables are logical tables that reference columnar data stored in cloud objects like Amazon S3 along with associated metadata. Okay, so this means that we have used Athena tables, right? And what is Athena table? It is basically the schema imparted on top of the S3 data, right? Similarly, it is gonna be using the Athena table format. I mean, we can query the tables, iceberg tables using Athena. I mean, it will use the glue data catalog, but inherently it has the support of the iceberg, which makes it a little bit different. Different how is that whenever you're using Athena tables, which is the schema for the S3 data, the metadata associated is with the glue data catalog. We don't see the metadata in S3. But when we create an iceberg table using an S3 path, you can see the metadata folder over there only. Okay, so that the actual data will be associated with the metadata. Uh, okay, now if I talk about the features, it is open source and open standards, promote flexibility and interoperability. Iceberg is supported by an expanding ecosystem of tools while avoiding vendor lock-in. So it's absolutely free and we don't have to get any license or install. Okay, not free. I mean, when you're using AWS, obviously the AWS billing, the cost will come up. But for Iceberg, differently, we don't have to get any license or pay any subscription to get access to it. Second thing is the support for schema evaluation makes it easy to change the table schema while maintaining compatibility with existing data. Iceberg handles schema mapping and stores full schema history. So that's the beauty of the metadata section that the Iceberg has is we can easily change the schema and we don't have to worry about it. Whereas if I try to use the conventional high tables, only Abro schemas were good with these evolution, right? Whereas if I try to use the OASI or packet, uh, there were were some glitches that came up while querying the historical data and whatnot. Third one is the time travel, allows querying historical table snapshots and rolling back tables. Iceberg's metadata store tracks every version of a table, allowing recreation of the table at any point in time. So it is same as the delta table, right? In the delta table also we have seen this feature time travel where based on the version ID of the timestamp we can look back into the previous data and we can roll back if required. Then is the ACID transactions, which is the most popular one, which ends up makes it why it's similar to data warehouse, even though it's been everything being worked upon the data. Provide atomic isolated table updates and deletes. Iceberg uses an optimistic concurrency model to implement transactions across concurrent regions. So one thing you need to understand that in Lakehouse architecture, even if you're using Delta Lake or Iceberg or whatever format, unlike the traditional data warehouse or RDBMS, when we update a data or when we kind of like modify the data, in that case, what happens is that on the physical table itself, the data is getting modified, right? But in Lakehouse architecture, what happens is the data that is getting modified, it will create a new version of it. Okay, it will create a separate version, and the previous will also stay in the physical data. That the both the previous and the latest one will stay, but based on the metadata, based on the transaction logs, it will identify which is the updated one, and that one will be reflected when you query the data or the table. Okay, so so the iceberg works the similar way in similar way as in data lake, and the ACID transactions are also applicable. However, we can uh, time travel or we can keep different snapshot of different versions. Partition encoding and file level stats dramatically reduce the amount of data scanned per query. Iceberg tracks min-max stats per column for each file, allowing filtering of unnecessary partitions and files. So partitioning is something that we have been seeing since Hive, right? One of the best techniques that the data lake has. One of the best features that the data lake has is that we can skip some of the data that we don't need to scan, but over here, another thing comes in is the file level stats. For each and every file inside the partition, there will be a min-max column value. Based on that, I mean, if I put that column value into the wire clause, it will only pick the uh, uh, it will only pick the recommended or the required file, and not. I mean, suppose there is an ID value from 0 to 100, it's being stored into file one, from 101 to 200 into file two, and so on. And if I try to query out data where ID equals to 504, then it will simply go to that file, which is having 501 to 600, that, right? So that's how the file skipping technique, and the similar way, I mean, the data lake works the similar way as well. So this makes the lake house, or this makes the query much more optimized and efficient, and also reduce the runtime of the query drastically. Right. So enough of the theory. Now I will get to my AWS console and I will first create iceberg table in Athena. Then I will insert some data using the Glue notebook, and then I will see how I can play with the data using the Athena table. Okay. So first I will go to Athena. So if I try to draw one of the very significant difference between the iceberg and the delta lake is that in delta lake the delta table and everything that was totally under the Spark catalog. Meaning I can, whenever my Spark job is running, I can do all those things. But once the Spark job is finished, if I try to do the update rate query from the Hive, that was not possible. I mean, that's one of the features that the Delta Lake didn't have. But whereas in Iceberg table, I can create an Iceberg table in Athena, which is running Presto behind the scenes. So if someone as an SQL developer who doesn't have any idea about Spark or Python and who wants to update or delete any row, he can simply just go into the Athena and do these things. Whereas for Delta Lake, it was not possible. You have to read the data as a data format using the PySpark or the Spark Scala, and then you have to do an operation. So that's the basic difference behind it. So first, I will try to create the iceberg table. So let me just copy the create table statement from here, paste it. So I mean, it's pretty much the same when you are using the Hive table. The only difference you will see that in the table properties, I'm putting the table type equals to iceberg. So that's the only thing we have to put in order to make it recognized as the iceberg table. And I'm putting location as an S3 location, the social bug iceberg. So this folder is not created at the moment. So when I create the table, this folder will be created, and you will see a metadata folder will be automatically created because in iceberg the data will be associated with the metadata as well. Okay, let me run this one. So it is completed, and I can see the table inside my glue catalog. So it is part of the glue data catalog, but iceberg has in order to use glue notebook or glue job to get access to the iceberg table, I have to use the iceberg job catalog as well, mapping to the AWS glue catalog, so it can work with the glue without any hassle. And if I try to look into the S3 buckets, I will see that folder has been created along with the metadata folder. So let me just verify it once. This is the bucket I've used. And yeah, I can see the folder has been created, and you can see the metadata folder is also created. So, and this JSON is basically having the schema of the table, which I just created. So I'm just going to get out of here. And now what I'll do, so this table is currently empty. It has no data, right? Because I just created the table. So I will insert data into this table using the glue notebook. So let me type in glue. ETL jobs, and I will initiate the notebook that I have already created and have been using so far. So it takes a bit of time to start the notebook, so I'm going to pause the video for the moment. So my notebook is up and running now. So, and these are the basic library imports or the code statements that you will see automatically coming up whenever you start a notebook. So I haven't written any of this. This will automatically come up whenever you start the notebook. So before hitting the import library statements, what I'm going to do, I'm going to set the configuration. So this is something that I have to do it externally. You won't see it coming up over here. So I'm just going to copy the configuration and paste it over here. So if you just look at it over, so if you just look at the configurations that I'm setting, it's basically the iceberg extension, along with it the job catalog of the iceberg job catalog. This has been mapped to the Spark SQL catalog is mapped to the icebergs catalog, along with the glue data warehouse catalog or the glue data catalog. Okay, so you can see glue data catalog is mapped to the Spark SQL job catalog, and also the iceberg Spark catalog is mapped to the Spark SQL job catalog and whatnot. So and also we have to use a warehouse directory. So this warehouse directory is going to be an S3 path. So I have put the dummy bucket temporary S3 path, and I will simply just run this one. Obviously, I have to enable the glue data catalog and the data lake formats. So these configurations, you don't have to go really deep dive into it. We just use the template, we just copy it and put it somewhere here, and it's pretty generic. It's not like that whenever you're using, it's going to be different. No, it's all going to be the same. The only difference is, however, is the warehouse directory. Obviously, you have to put your own bucket. Otherwise, you'll be simply redirecting it to my bucket, and it will store everything, the warehouse directory and metadata, into my bucket, which is not which is not recommended, and obviously you won't be able to access my bucket because of different IAM policies. So I have set the configurations that are required. Now what I'm going to do, I'm going to hit this one, which is just importing all the required libraries such as the Spark context, glue context, and to start the job. So let me hit this one. The session is getting created. It takes some time with the configurations that I have set. So you can see it over here. So let the session be created. I'm going to pause the video again. So my session is finally created. Now what I'm going to do, so my purpose over here is to insert the data into this table, right? Which is the social circle iceberg. So I have these 4 columns. So I have the similar format data with the similar schema into my S3 bucket line. So what I'm going to do, I'm going to read this data, that is the social circle output, and I'm going to copy it to my iceberg table. So that's all I'm going to do. So first I have to create a data frame. Either I can create a Spark data frame or dynamic data frame, whatever. So I'm going to create a dynamic data frame, and then I will convert it to a Spark data frame. So in order to read directly from the S3 path instead of the catalog, we have to use the from options instead of the from catalog. From catalog will go to the glue data catalog and search for the database and table name that you give. But from options will help you play with whatever raw format data that you want to read. So this from options take 3 arguments, 3 prime arguments. One is the connection type, that is going to be S3. Then there is connection options. That is going to be a dictionary of different key value pairs. First key is the paths, and the value will be under the list, whatever the path that I just copied, the S3 URL. So this is the data that I want to read, and I'm going to put recurse set to true, which means whatever folders, subfolders inside that path all should be red. Okay, and last but not the least is the format. Format is going to be Parquet, because there is the Parquet format data lying in that path. So let me print the schema out. And also just display the data that I just read. Okay, there is a typo over here. Yeah, so this is the schema over here. Serial number, name, age, number of friends, and this is the data which you're seeing coming in JSON format or binary shape format. So I see a slight difference from the schema that has been read and also the schema that I have defined in my iceberg table. So if you look at the serial number, it is SR number only, and there is no dot or full stop as such. But if you look at over here, there is a dot over here. So this will create a problem because I have to remove the dot, otherwise the data, I mean, it won't be able to understand the schema. So what I need to do is first, let me just convert it to a Spark data frame, and then I will use the with column rename. I will use this method to convert the serial number dot to only serial number. Right, now let me just do a show, or let me just create another data frame out of it and then do a here show. So let it run. I'm going to pause the. So now the dot has been removed and the schema looks similar. It has string, string, integer, integer, and in my bucket, sorry, in my iceberg table, string, string, integer, integer. Now it shouldn't have any problem in ingesting the data. So this DF contains the Spark data frame, and I'm going to write it to the iceberg table. So to write it to iceberg table, it's pretty much the same to writing into Hive table. The only difference is over here, I'm going to use the format as iceberg, which was not there previously. So this will mean that the data format should be iceberg only, where I can do all the CRUD operations and everything. Then I will use the mode as append because the table is already created. If had I been using mode as override, it will try to replace the table even if it is there. So I'm going to use mode append, and then the path. Yeah, but path is also optional. I won't be putting it here because I just remember that while creating the table, I have already put the location over here, right? So I don't have to emphasize the path over here. No need for that, because by default, if I'm using this table, then the path that it will choose is obviously going to be whatever location that I've put in the SQL definition. So the next is the save as table, and I will put the database name and table name. Looks like everything is right for my data. Mode append. Okay, let me just run this one. Okay, so there is unable to fetch table, social circle iceberg, storage format cannot be null for table, social circle iceberg. Let me try with the job catalog. It's probably not able to understand. It's probably trying to find a new data catalog, normal Athena table. Let me see if this works. Yeah, now it is written. So yeah, I got what was the failure. The reason being, since in the configurations we are mapping the job catalog with the Glue data catalog and Spark catalog. So whenever you're trying to write to AWS, I mean the Athena iceberg table. So iceberg tables not only you have to mention the format, but also you have to mention the catalog. So that is the job catalog. Okay, if you remove this one, if like the previous option, I was using only data hub dot social circle iceberg. So it was trying to find a data hub social circle iceberg in the glue catalog only. That is being recognized as an Athena table, but it's not. It's an iceberg table, and it's mapped to the job catalog. So that is the reason you have to specify the catalog as well. So let me see if I can see data into my table. So let me just do a select start query and check if the data is available. Yeah, the data is now there in the social circle aspect. So that's all good. I will go to my bucket and I will check in the folder. Yeah, so you can see this data folder has also come up, which has the bucket format data. And it creates a different files. So I mean, it creates the files, the so it has some layers, like there's the metadata layer, then there's the file layer. So inside the folder data folder you see this folders, I mean, which are having mapped to different metadata, and accordingly the files you will see under each and every folder. So no need to worry about this. Whatever the data structure is, let it be. My only concern would be the table. So let me see if I can run any update query on it. So I'm gonna use a silly update query just to play with the data. Update table, and let me just do set number of friends to 100. To 100 where name equals to Brunt. Okay, I can see this Brunt too many times coming in. Brunt 1, Brunt 2. So it's having 174, then 516. So I want to change to all of them to only 100, right? So let me run this query. Okay, it's completed. Now let me look at the data where the name is Brunt. So obviously all of them will be having 100 only, right? So select star from table where name equals to Brunt, and yeah, all of them having 100, right? So what if I want to delete the Brunt overall? Can I do it? Let me just check. So just remove this, delete from social circle where name equals to Brunt. Now let me run the query again, having the name equals to Brunt. Okay, still these are coming in, not sure why. And the number of friends. Did my query run or not? Something is wrong. Alright, now so what I understand is the metadata gets refreshed a little bit later. I mean, I just did nothing. I just ran this a couple of more times. I tried to MSC repair the data. but now none of it is working. So I just reran this query again, and this time I don't see anything coming up. So those rows have been deleted. So that is confirmed. So basically, the metadata takes a bit of time to refresh. So that's the reason we were seeing those data coming in again. And so this is how we can edit the record. So that's the beauty of Iceberg. I mean, if you remember using only Athena table, these operations were not permitted at all. So let me just try another table. Let me just select star uh, from EV population data, which is a normal Athena table. And let me check if the update queries. Okay, it doesn't have anything. Let me check the ORC one. This also doesn't have anything. Strange. Okay. Anyways, so the fact of the matter is, if I try to run the same update queries or anything on the normal Athena table, then that was not permitted. I mean, I can't update or delete any rows from any normal Athena table because that is much like the data lake concept. Having the immutable format means whatever data is, uh, you just have to stay with it. That's it. Okay, so there are different ways I can check the snapshot. So whatever operations that I perform, so I can check the snapshot by checking the history. And to check the history, I just have to give the table name, then dollar history, and this will show me the different snapshots that have occurred over the time. So you can see the snapshot IDs and for any particular time. So if I take the very earliest snapshot ID and check what how the data looked over there, so I can do that as well. So what I have to do is just select start from table. Let me just get away with the codes. Uh, for version as of now, give the version ID, and if I run it, so you can see everything is coming over here. Okay, so that's how basically we can. So this is a time travel feature. Okay, now I can check all the things. So let me for version. Let me put a where clause where equals to brunt. Okay, so this doesn't work. So this doesn't show anything. Maybe I have picked the wrong snapshot. Let me look at the timestamp 625, 620. Okay, yeah, I had picked the latest snapshot, so obviously the brunt name won't be there. So let me change this one. Okay, now you can see the brand is coming in, right? With the actual data, you won't see the number of friends 100 as well, because this is the earliest snapshot ID, meaning this is the first picture of the data, the how it was. So this is an example of the time travel feature, right? So you can simply select this data frame of this data and then insert into whatever data in the original table as well. So you can roll back if you feel that some of the operations that didn't go correctly. So these are the features that the iceberg table has, and that's how we can build a lake house. We can ingest data, we can do the operation of the pre-processing using glue, and then we can sync the data into an iceberg table. So the business users, whoever want to do any sort of warehousing thing, they can do it over there. So that's all from this session, folks. If you need more clarity on each and every topic, just reach out to us, reach out to TechSpark. We provide 100% job assistance, and we also cover most of the data engineering tools and stacks such as AWS, Hive, Hadoop, SpicePark, and Kafka as well. So just if you need any guidance or any queries, just reach out to us and we will help you out. Signing off from this session. Ta-ta.
Contact us for the free job assistance. We will help you to get the IT job. Please like, subscribe, and share the channel for more regular updates from TechSpoke.